In this video, I want to cover the difference between using basic communication with Siemens devices over open drivers. Say here, for example, where you see TCP/IP, where basically malware applications can actually listen in over a network, and where what I would recommend is that those controllers are actually configured to become OPC UA clients with Kepware. So I feel it's best to provide a kind of a network example here. On a typical network architecture, this is a simplified one here. Say, for example, I have an OPC server. Say, for example, Kepware is running here, and it's basically looking out at devices over a network. And essentially, when you have, again, the open driver of TCP/IP, you're not authenticating, and basically the values and variables and so on inside of these controllers, they're actually open, right? So essentially what that means there is that when you are, say, for example, when you're looking at your communication here, it's that the put get feature for say, for example, for data blocks and so on, that they're open, right? So that essentially means, say, for example, I have this PLC. I just have an example data block here, and say if I go into properties, what you'll find is that there's no protection that's there, right? Essentially, that the data block is open, and effectively when you go in, right, you're opening up the network card, right, and you're opening up the variables that are effectively inside, right? So for me, in terms of the OPC server itself, right, getting it working with Kepware can be a little bit tricky, right? The core thing is that you have the actual authentication method set inside the PLC. Here I'm just looking at the hardware settings for the controller, that you actually have a genuine certificate. That's a key thing. So you have a certificate, and again you have authentication, and then you actually have an actual user set up in the PLC. And essentially, if I'm to go back to Kepware, basically what that means here is that we have an actual method of authentication. This is the authentication on this side. That's here, that we actually have the certificate has been loaded into the actual server PC Windows system, basically, that's running Kepware, right? And then what we actually have is that when we actually go to set up our connection itself, that we actually have the UA server that's here. We have the exact proper kind of security policies that are in place, and essentially then that we have the actual username and the password built in, right, to Kepware itself, right? So you have none of that when you actually have when you're using the open driver again. So here, say, for example, what I'll do is I have, say, for example, these two particular variables, which are here. Here we can see they're 80 and 28, and they're looking live then at, say, for example, at this particular guy. So I'll maybe give him a click, and say what we'll do is we'll just go online, and we should be able to see him there now quickly. He's just gone off and he's searching for him. Very good. So here we can see the 18 and the 28. And what I can do, you see, and this is a real problem, where what I can do is I can actually go off myself, and I can actually maliciously change the value. So say, for example, I go off, I'll read, it says 28 here. Say, for example, this is a customized application, and I can just write any random value I want. It's essentially a case that if there was a piece of malware that was written to incorporate the open drivers, essentially it's just all you need is one of these items to be infected. It goes off, it explores the network, finds all the Siemens PLCs that are there, and it essentially, it can just go and it can create havoc, and that is a huge problem. It means that the switches in the middle, that the switches have to be very, very well configured. So say, for example, I have here, this is basically a firewall scalant switch, and the rules this can do a lot of protection to devices. But the reality is that the Siemens devices, like say for example here, like this NS7 1500, that guy really can do a lot of protection himself, that you shouldn't be depending on the firewall rules to do all this protection for you. It should really be at the device level, certainly for myself. So essentially, if I go back myself, then if I go off and I take a look at, say for example, if I have the OPC UA connection that's here, it's a case that in order for me to modify these values, if I actually want to go off and do that, I need to essentially, like say for example, I have an application here again where I go off, I have to explore. I have all of these open channels that are here, but in particular, say if I had it locked down in the PLC, that I have to use this encryption model here. I have to sign every time. All of the packets are encrypted when they go off over the network, and I have to supply a username and password. And that essentially then it means that if there is any particularly vicious piece of malware that kind of comes along, that you're not having this weak point of Kepware looking down at the devices. What you're doing is you've made sure that, say, if you want to go off and authenticate to Kepware itself, that you go off and you authenticate to Kepware, but that Kepware authenticates against the PLCs also. That is absolutely the kind of the key thing. So in the diagram, we authenticate from the OPC server down to our controllers, and say, for example, our historian, that the historian collector authenticates to the OPC server also. So there is no weakness in the chain. Thank you very much.